In this video, we're going to do a marginal revenue example. In microeconomics, marginal revenue is defined as being the additional revenue that is generated by increasing product sales by 1 unit, right? So if you sell one more, how much more revenue would you make? And in a perfectly competitive market, that additional revenue generated by selling this additional unit of whatever good you're dealing with is equal to the price that you're able to charge the buyer of the good. So here we're given a revenue function, not marginal revenue. We are given revenue. All right, so the revenue from selling X washing machines, that's my X value, is given in dollars. R of X equals 20,000 times 1 minus 1 over X. That represents revenue in dollars. So part A asks us to find the marginal revenue when 100 machines are produced. So marginal, basically that means we're going to find the derivative. The marginal revenue means we need R prime of X. Now, looking at this, a lot of you might say, well, we have 20,000 times this quantity, 1 minus 1 over X. Let's use our product rule. However, remember, we said whenever possible, we want to use algebra to try and simplify this. So if I distribute 20,000, that gives me 20,000 times 1, which is 20,000, minus 20,000 over X. And if I want to make this look like a polynomial, that divide by X can become times X to the negative 1. So this represents my revenue function. For part A, I have revenue is 20,000 minus 20,000 X to the negative 1. Therefore, my marginal revenue, R prime of X, the derivative of 20,000 is 0, minus, I've got 20,000, taking the derivative here of X to the negative 1, that would be a negative 1, X, subtract 1, we have negative 2. So my marginal revenue function, R prime of X, is 20,000, positive 20,000, X to the negative 2. So if I wanted to find the marginal revenue when 100 machines are produced, that would be R prime of 100, which equals 20,000 times 100 to the negative 2, so that's 100 squared, 10,000, and that's going to go under the 20,000 because we have a negative 2 power, so we end up with 2. So the marginal revenue is 2 additional dollars. So part B, let's estimate the increase in revenue that results from increasing production from 100 machines to 101 machines. In this situation, B, that would be R prime of 101. So R prime of 101 is 20,101 to the negative 2. Simplifying that, we get 1.96. So that would be $1.96. If we look at the limit of marginal revenue as X becomes increasingly large, what happens to the function? So in this situation, the limit as X approaches positive infinity for R prime of X, for the marginal revenue, well, that's the same as 20,000 over X squared. 20,000 over X squared, moving that to the bottom, turns it positive. And if we look at this limit to infinity, we've already discussed limits to infinity. We have a rational expression here. The degree of the numerator is 0. The denominator is quadratic, or degree of 2. Since the numerator is less than the denominator, this approaches 0. So if we think about trying to interpret this and think about what this means in real life, the increase in the revenue, the actual extra revenue you will be making, as the number of items increases without bound, that's going to approach 0. So at a certain point, there is no reason to make or to try and sell more values because you're not going to be making any extra revenue. You will have maxed out your revenue in a sense. And if we think about, the additional revenue that is made, right? If we look at this difference between R prime of 10, and we say, well, let's subtract, not R prime of 10, R prime of 100, subtract R prime of 101, what is that difference? And it's about 4 cents. So going from 100 units to 101 units, we only make about 4 additional cents in revenue. And as we increase the number of units, in this case washing machines, that are sold and produced, our revenue margins become increasingly smaller, right? So at a certain point, again, like I'm saying, there's no reason to try to make more washing machines for sale because we're not going to be creating that much additional revenue. I'm not an economist, so I hope I explained that in a way that it makes sense to you. But when we're doing a problem, really what we want to make sure that we understand, especially with marginal revenues, we have our revenue function. Marginal is the rate of change per additional unit. Okay? So what is that rate of change? How did the revenue increase or decrease with the addition of that extra unit?